Good morning, students. Now, I hope you all have done my work and you remember my previous class. A quick recap. In my previous class, we studied rest and motion. We studied distance and displacement. We studied uniform and non-uniform motion. Today, we will go a little further. How? Let us see. I have this Buddha reference point. This elephant now elephant starts and moves to a distance, say 1 kilometer in 1 hour. My elephant starts and moves 1 kilometer in 1 hour. My caterpillar also tries to move and moves 1 kilometer but in 10 hours. Now, both of them covered 1 kilometer. But elephant covered in 1 hour and caterpillar covered in 10 hours. Suppose I have to give him a prize. Of course, the elephant will say, I want prize because I covered in less time. But caterpillar can also say, well, I covered the same distance, so I also need prize, though I took little longer time. People came across this problem and they found the solution. The solution was who completed the distance faster than the other. Of course, the elephant covered the distance faster than the other. Elephant covered the distance faster than the caterpillar. To give this idea a technical name or a scientific name, people came out with one more term in physics. And that term, can anyone guess? Okay. Of course, yes, that term is speed. You might have come across this word quite frequently in your life. But physics defines speed as the distance covered per unit time. Repeat. Speed is the distance covered per unit time. So if a body covers distance of 40 km in 1 hour, the speed of the body is 40 km per hour. If a body covers 80 km in 1 hour, the speed of the body is 80 km per hour. That is our day-to-day experience. This is how we deal with speed. Speed in SI unit is expressed as meter per second. Speed in SI units is expressed as meter per second. Why meter per second? Why not kilometer per hour? Because SI unit of distance is meter and SI unit of time is second. So, the speed is meter per second in SI unit. Well, now we got one more term in our dictionary of physics, that is speed. Speed can be uniform speed, can be non-uniform speed. When a body covers equal distance in equal interval of time, the speed of the body is uniform speed. When a body covers equal distance in equal interval of time, the speed of the body is uniform speed. On the other hand, if the body does not cover equal distance in equal interval of time, the speed of the body is non-uniform speed. In our day-to-day life, we come across non-uniform speed. Say, in a journey from Delhi to Agra, a car starts with 40 km per hour speed, reaches 80 km per hour speed, then goes to super highway and reaches 100 km per hour speed. By the time, if there is any breaker or anything like that, reduces the speed to 60 km per hour, again goes to 100 km per hour. Means the speed is not uniform. When the speed is not uniform, we come across one more term in physics that we call average speed. When the speed is not uniform, we consider one more term in physics, that is average speed. Average speed is defined as the ratio of total distance covered to total time taken. Average speed is total distance covered upon total time taken. Say, from Delhi to Agra, the distance is 200 km and the total time taken to complete that 200 km distance is 5 hours. So, the average speed will be 200 divided by 5. Get that numerical done, how much it is? 200 divided by 5. That will give you 40 km per hour. The speed of the car was never only 40 km per hour. It was 40 km per hour, 100 km per hour, 60 km per hour in the journey from Delhi to Agra. But what we have taken? When we take the total distance divided by total interval of time, the average speed of the car comes out as 40 km per hour. Now I think you got the idea of average speed. In our daily life, we talk about average speed, which is generally considered as speed, and in our day-to-day units, we express speed in kilometer per hour or mile per hour, whatever it can be. 50 km per hour speed means a body has covered distance of 50 km in 1 hour. In SI units, speed is expressed in meter per second. Now, this problem comes to students when we deal with numericals. When we deal with numericals, the question gives kilometer per hour and tells find out meter per second, or question gives meter per second and tells you to find out in kilometer per hour. Well, how to solve this problem? To solve this problem, we take, what do you call it? Conversion factor. We have made one conversion factor which will make our work easy to deal with this conversion, kilometer per hour to meter per second, meter per second to kilometer per hour. For example, speed is in kilometer per hour and you have to express it in meter per second. Speed is in kilometer per hour and you have to express it in meter per second. Now look at that presentation on my computer. Here what you see, 1 kilometer per hour equals 1000 meter divided by 60 into 60 second. That is, when you cancel all that, it is 5 meter upon 18 second. That is equal to 5 by 18 meter per second. Means what? Means we can express 1 kilometer per hour as 5 by 18 meter per second. Now the question comes. A body is moving with 36 kilometer per hour. Express its speed in meter per second. What we can do? Just see, look at my computer and see what we can do with that. There. Here, in this example, what we have done? 36 multiplied by 5 by 18 meter per second. That is equal to 10 meter per second. Short and quick. How? Using the conversion factor. 1 kilometer per hour equals 5 by 18 meter per second. Otherwise, if you don't use conversion factor, what you get? 36 kilometer per hour equals 36 into 1000 divided by 60 into 60 second. That comes out on all this calculation 10 meter per second. Now, which one is easier one? Of course, the use of conversion factor. Another example. That 90 kilometer per hour, simple, 90 multiplied by 5 by 18 meter per second will give you 25 meter per second. How? Using, of course, using the conversion factor. Now you got some more questions there. You will use your head or paper pencil and get me the answers. Let us move further. Now suppose they are asking or they are giving you 1 meter per second to convert it into kilometer per hour. Here 1 meter per second will be equal to 1 upon 1000 kilometer whole divided by 1 upon 60 into 60 hour. That on multiplication, division, all that, you can get it 18 upon 5 kilometer per hour. So we have 1 meter per second equals 18 upon 5 kilometer per hour. Okay? Fine. So you got the conversion factors. Keep these conversion factors in your mind when you are doing. I'll give you little exercise. Go back to my computer and just see. using the conversion factor or use the conversion factor to find the following: 50 meter per second, 45 meter per second, 35 meter per second into 75 meter per second into kilometer per hour. That is also little homework or little exercise which you do for your mind. Little pause. Now, once you are comfortable with converting this quickly, then you will be very comfortable with the numericals which you come across while solving the questions. Here, one question. Is speed a vector quantity or a scalar quantity? Think. You know, in my previous class we talked about distance and displacement. Here, what we have taken? Distance covered per unit time is speed. Then, can we call the displacement covered per unit time also speed? Think. If your answer is no, then you are right. We cannot call displacement covered per unit time as speed. Why? Because distance and displacement are two different things. So, displacement covered per unit time is called velocity. Repeat. Displacement covered per unit time is called velocity. Now you know speed and velocity are different terms. Speed, by the way, is a scalar quantity, whereas velocity is a vector quantity. Why velocity is a vector quantity? Because when we deal with velocity, we have to specify direction. How you will get that direction? We will get direction from the displacement, because displacement has direction in it. If you say 40 km per hour is speed, you cannot call 40 km per hour is velocity. You have to call 40 km per hour in north as velocity, or you have to call 40 km per hour in south as velocity. So, velocity and speed are different things. Think how many differences you can find about speed and velocity. Well, we got uniform speed and non-uniform speed. So, we can also have uniform velocity and non-uniform velocity. When we come across non-uniform velocity, we have to consider another term, and that term is average velocity. Repeat, average velocity. If a body is moving with initial velocity u and final velocity v, the average velocity will be u plus v divided by 2. Repeat, the average velocity will be u plus v divided by 2. In language of physics, we call average velocity is the arithmetic mean of initial and final velocity. Is it clear? In physics, we call average velocity as arithmetic mean of initial and final velocity. So if a body has initial velocity 10 meter per second in north and final velocity 20 meter per second in north, the average velocity will be 10 plus 20 divided by 2, that is 15 meter per second in north. Clear? When you get average velocity consideration, one thing you have to keep in your mind. Here, the acceleration should be uniform. Now, what is this acceleration? We will discuss in next class. Quick recap what we have done. Today we learned what is speed. Today we learned what is uniform speed. Today we learned what is non-uniform speed. Today we learned what is velocity and what is average velocity. With all these basic concepts, we will be doing numericals. And the more numericals you do, the more you will be able to understand the concept in a better manner. I will give you on this WhatsApp group the questions. And I hope all of you will do it right or do it wrong, but do it. What is important is do it. With this, I would like to thank some of my students who did my work and posted me on my group, or they posted on my email ID. Somebody reacted on the YouTube channel only, and some of the questions were really good. Fantastic. One student asked me about, sir, what will be the equation when reference frame itself is moving? Well, that is a big question. Leave it for your 12th class. One great student asked me, sir, what will be our motion when you are moving on a escalator? Somebody asked, sir, how we will define our motion when